Science Made Simple with Mr. Sani.
Hello students, today we want to look at the measuring instrument. Measuring instrument refers to the instrument used to measure the quantity in physics. The quantities that we can measure are the basic quantities. From the basic quantity we can derive the quantity for the derived quantity. In our last edition, I told you that we have three common basic quantities. These are the length, mass, and time. These are basic quantity behind the dependent quantity. The instrument used to measure length, we have for length, we can make use of our meter rule, the one we have in our mathematical set. We can make use of our tape rule for longer distance. We can make use of our Vernier Caliper. You can also make use of caliper, or you can also make use of micrometer screw gauge. Micrometer screw gauge. All these instruments are used to measure the length of a body. The length is the distance between 2 points. You know, from the distance, from the calculated distance, you can also derive formula for area, volume, and so on. So, for the area, we have area to be equal to length times breadth. Area of a rectangle is equal to length times breadth. The longer side multiplied by the shorter side. The length is represented by L, while the breadth is represented by B. Both the length and the breadth, they are measured in meter. They are measuring a distance between 1 point. So meter times meter, we have meter square. So whenever we see meter square, that means we have area. For volume of a regular body, we have length times breadth times height. Length is measured in meter, breadth is also measured in meter, height is also measured in meter. Everything will be meter cube. So if you want to measure area, you derive the formula from the basic unit called length, from length. So that's how you can measure area. Ditto to the volume from length. So the second one is the mass. The mass of an object is the quantity of matter in that body. So the mass of an object can be measured by the chemical balance, beam balance, lever balance. We have different types of the chemical balance and the beam balance. So, and don't forget, I told you that mass is measured in gram, milligram, kilogram. Out of all these units, we have the kilogram as the standard unit. That means whatever you measure in any unit must be converted to the kilogram. And let me quickly tell you weight, the weight of a body, the difference between mass and weight. Weight is the effect of the acceleration due to gravity on the body. That is the force acting on the body as a result of the gravitational pull of the earth. So weight is defined as mass times g. That g is the acceleration due to gravity. The acceleration due to gravity, the constant value for g is 9.8 meter per second square. That's the g. Our g is 9.8. So whatever you have as your mass, you multiply it by 9.8 to get the weight of the body. Weight is measured by spring balance. Weight varies from one region to another, while mass is constant throughout the universe. The mass of a body is, the unit for the mass is kilogram, while the unit for the weight is Newton. So I told you weight is the force acting on the body as a result of the gravitational pull of the earth. So weight is force. This one is the quantity of mass, is the quantity of matter in the object. Another physical quantity, which is the third one that is very common, is the time. Time is the interval between two events or duration of an event. Time can be measured by our wristwatch, wall clock, stopwatch, so the unit for measuring mass are the seconds, minutes, hours, days, months, year. You can remember this thing in your elementary mathematics. 60 seconds make 1 minute, 60 minutes make 1 hour, and so on and so forth. So whatever you measure in mass, you must convert it to the standard unit of mass, which is the seconds. So now we want to go into look at another aspect, which is called dimension. Dimension is the physical nature of the quantity. That is the relationship between the quantity and the physical nature. So for dimension, the dimension for length, we write it in capital letter L. The dimension for mass, we write it in capital letter M. Dimension for time, we write it as capital letter T. For length, we have capital letter L as a dimension. For mass, we have the capital letter M as the dimension for mass. For time, we have capital letter T. Now, if you want to calculate we want to get the dimension of velocity. Let's say velocity. Velocity is the rate of change of displacement with time. That is, velocity is displacement over time. Displacement is the same thing as distance, but it has direction. Displacement is vector quantity, while distance is scalar quantity. Displacement here, we can see our displacement is distance. You can see instead of is distance over time. Distance in a specified direction, that is displacement. So from here we can say our velocity here is equal to L over T. You want to find the dimension for velocity here. You can say velocity is equal to L over T. You want to bring everything on a straight line. This T will come up. It will be negative 1. Now when the T is in denominator, it's a positive. But you are bringing the T to the numerator. So it's going to change the value to -1. Another quantity, this is also a derived quantity that I want to look at, is acceleration. Acceleration is defined as the change in velocity with time, that is our acceleration is equal to velocity over time. Velocity in the last example is LT minus 1. Then time is T. So to get the dimension for the acceleration is going to be, we bring this T up as we did in the last one. It will be LT minus 1, T minus 1. It's going to be LT minus 2. That is for acceleration. That is for acceleration. Another quantity you want to look at is force. You know, I told you that force is the effect of the acceleration due to gravity on the object. That is the force acting on an object as a sort of gravitational pull of the earth. We have our F to be mg. For force, you can say our force is the same thing as ma, because this g is acceleration, but in this case g is the acceleration due to gravity. Y is the linear acceleration. So our F is the same thing as ma. We have m from here, capital letter M, then acceleration from the previous example is LT minus 2. So the dimension for force is MLT raised to power minus 2. You can also do that of the pressure. Pressure is another derived quantity. Pressure is defined, the pressure of a body is force per unit area. Force from our last example is MLT minus 2. And our area is length times breadth, that is L squared. Length times breadth, everything is in length, L squared. So it's going to be, we want to put everything on a straight line. It's going to be MLT minus 2. Bring this one up to be L minus 2. We have one L here. This L is plus 1. We have plus 1 minus 2 is going to be M L plus 1 minus 2 plus T minus 2. So if you calculate plus 1 minus 2, it's going to give you m l minus 1 t minus 2. m l raised to the power minus 1 t raised to the power minus 2. That is for the first. You can also try to do that of density on your own. Density is mass over volume. Mass, you represent mass with capital letter M. Volume, from what we earlier discussed, volume is length times breadth times height. Everything is in that one is L cube. So you have your density to be mass over volume. That is M for mass, volume L T this is about 10. So your density will be M L minus 3. And so on and so forth. Thank you.